grade your Moodle quizzes. Like I mentioned, the auto grading wasn't going to work very well. You're putting in short answers because I can't put every single permutation about how you might answer the questions. So I went through and graded them. They'll also be graded now, so you should be able to go in and see what your grade is officially, if you will. I also put comments in on where if you made a mistake about what the mistake was. So that'll also be a Moodle, but of course, if you want to come in and ask me questions about it, happy to answer those as well. Hope, did you want to say something too?
Yeah, I could do a review session for the test. I have kind of two times I'm thinking, but if you guys prefer one or the other, I would love to know that. So I could either do Thursday afternoon or Sunday at 1. So I guess.
So what was it? What would you rather do, a Thursday or a Sunday one? Is what she's asking. Sunday be better. So Sunday at 1. You want to do it in the math center because the math suite will be locked.
Yeah.
Yeah. So do it in the middle room, maybe in the math center.
Okay.
Yeah. So math center is Schilling 204. So 1 floor down, almost all the way to the end of the hall. It's on the right. Then the math center before that's where it is. There's a middle room. Hope can unlock. You have the key to the math center, right?
Yeah.
Yes. Okay. So Hope will have it unlocked. Then you'll do the review, I'm sure, in the middle second room. There's a middle room inside. There's the chalkboard and stuff. So that'll work. Yeah. Okay. Cool. All right. So Sunday at 1. I also want to ask you. I think you can email the class too from Moodle.
Okay.
But let's check on that and make sure you actually do that. You in tomorrow, right, for your office hours?
Today.
Oh, today. Okay. Well, yeah. Just come see me and we'll see if we can get that worked on Moodle as well. Yeah. All right. All right. So on Friday, I'll also hand out review sheets. I'll also get a practice exam posted on Moodle for you as well. So you'll have that to work through. So we'll actually, I'll hand out a review sheet in class on Friday. I'll have an extra review also posted on Moodle, and I'll have a practice exam. So you'll have plenty of things that you can go through and work on at the review session too. All right. Any questions at all before we finish up section 2.5 and start 2.6 today? 2.5, 2.5 homework will be due tomorrow, I believe, if I remember correctly. Double check, but I think it's due tomorrow. But in any event, let's continue on with our discussion of linear models. So we talked about what a linear model is, and then we also talked about how to find them, and we did one example with a word problem. So let's do a couple more word problem examples before we switch gears and go into the next section. So this should be the next problem on your packet that we talked about last time. Barb driving home from vacation. Set our car on cruise control, so we'll be traveling at a constant speed the entire time. After driving for 3 hours, still 740 kilometers from home. After 6 hours, now it's 461 kilometers from home. And asks how fast is Barb driving. So remember again, when we set up something with a linear model, we're basically looking for two things, right? Linear model has this form where you've got a constant times x plus another constant. That's kind of that mx plus b form you've probably done before with lines. The a represents our slope again. The b represents the y-intercept if you're thinking about it in terms of lines. For word problem purposes, that slope corresponds to what? What did we use for the slope in the word problems? What did we always find? Yeah, the constant rate of change, right? That constant rate of change, right? So in this case, there's two pieces of information given to us. So how would we figure out what the average rate of change is?
F of b minus f of a over b minus a.
Okay, so yeah, the formula for that is f of b minus f of a over b minus a. What are we going to use for a and b in this case? What would be for what they've given us? What are we going to use for the a and the b? 3 hours and 6 hours for the a and the b, right? Okay. So if I use 6 for my B and 3 for my A, I'll have 6 minus 3 on bottom. What numbers go on top? Yep, 740. Good. So again, remember we want to keep the order the same, right? If I use 6 minus 3, I want to make sure I use the 461 first because that's the distance from home at 6 hours, after 6 hours. What did you get for that when you simplify? Negative 93? Okay. Okay. So what would the units be, by the way? The top is measured in kilometers and the bottom's in hours, so it would be kilometers per hour. Good. If I wanted to do that. What's the negative representing, by the way? Why is the basically speed here being negative? Why is it negative?
Yeah, because she's going back to home.
Yeah, going back home, right? Getting closer to home. So the distance from home is smaller. Yeah, as time goes by, right? So how fast is she? The problem's asking how fast is she driving? She's driving 93 kilometers per hour. Good. Now, if we're setting up the linear model, then the A value will be what? It'll be positive or negative in this case, the way we have got the model set up. It'll be negative, right? Because we're getting closer to home again, right? Okay. So for the next part, it says, how far from home was Barb when she started driving? Well, we've got the linear model so far that we found is negative 93x. I still don't know what the B is, right? It says, how far from home was Barb when she started driving? What value would you be looking at for x that would represent when she started driving? What would the x value be when she started driving? How long have you been driving for if you just started driving? 0, right? Yeah, it hasn't traveled at all, right? So this is asking for what? If you're looking for when the x is 0, what are you looking for? What value are you looking for? Yeah, the y-intercept, right? That's exactly what you're looking for. If we're looking for when the x is 0, we're trying to figure out what the y-intercept is. We're trying to figure out what b is, right? Pretty much in all of these problems, you're going to be looking for the a and looking for the b, and it's going to ask you something about it at some point, right? In this case, when she started driving, she's been driving for 0 hours, so this is asking you for the y-intercept. What can I do to find the y-intercept in this case? How can we find it?
Plug 0 y.
So if I put 0 in, I would get what out? I would get b, right? And that's what I'm trying to figure out what it is, right? So what else might we try? Bless you. What did we do last time to help us figure out what the y-intercept was?
We can use the points that we already have.
Okay. So what would we do then?
Plug in the 6.
Okay, so if you plug in the 6, you're supposed to get out 461, right? Or you could plug in the 3 and then you would set it equal to what? 740. You could use either one. You should get the same answer. It's also a good check to make sure you're doing the problem, right? If you do them both and get the same answer both times, okay? When I plug in the 6 into the right-hand side over here, we would have negative 93 times 6 plus b. If I do 93 times 6, what do we get? Okay. So then we would add our 558 to the other side and get
1019.
And again, so it's asking how far from home she was How far?
1,019 kilometers.
Kilometer. Good. Okay. Questions on that part? Okay. That next part. How far from home was Isbarb when after 8 hours and 15 minutes? So let's ask this again. Think about what your model is representing. What did we plug in for x in the previous part? Did we plug in a time or did we plug in a distance for x? Time, and we got out a distance, right? Okay. So did this give you a time or does this give you a distance? This one's giving you a time, right? So what do you think you want to do with the time? Plug it in. Yeah, exactly. So we want to plug in 8 hours and 15 minutes. 8.25. Good. I need to convert it to a decimal, right? Probably the easiest thing to do. 15 minutes is a quarter of an hour, so it'd be 8.25. So we'd have negative 93 times 8.25 plus 1,019. That looks like a good problem for a calculator. Good. And again, the units on that would be kilometers. Good. And it makes sense that it should be closer to home because been driving longer, right? We were given 3 hours and 6 hours. It's now 8 hours and 15 minutes. It should be closer to home. Okay. So in this case, we were given the time, plugged it in to find a distance. This one says, how long will it take for her to drive home?
So we want it to be 0.
Yeah, so good. Exactly right. So we're trying to figure out a time. We're trying to find an x, right? To figure out how to find x, we need to set this equal to something, right? We need to set f of x equal to something. We want to set it equal to what in this case? 0, because when she gets home, she's 0 kilometers from home, right? So we'll solve f of x equals 0. So f of x is negative 93x plus 1,019. What should we do first? Good. Subtract the 1,019 over. And then divide by negative 93. And get x is equal to
10.96.
Okay, 10.96. And that'll be what units on that one?
Hours.
Hours, good. Because it's referring to the time. Okay. Right. Work on the next one for a few minutes, and then we'll chat about it. And if you've got questions about anything, holler at either me or Hope. We're happy to help. At least I hope Hope's happy to help. Just identifying which one should be the input and which one should be the output. So which should be your x and which should be your f of x. So it's telling you that you've got, if it has a value of 3,500, it costs $189.50. If it has a value of 3,900, it costs $29.50 or $297.5. So what should you be plugging in and what should you be getting out?
Put in the the 3,500 and the 5,900, and then you get out the value of that much to insure.
Yeah, so good. So the input, the way it's written for us, is it should be our input should be the value of the ring, and the output should be the cost of the insurance. Just the way it's set up for us, right? Okay. So if we do our average rate of change, then our function value should be on the top, and the value of the ring, the cost of the insurance should be on the top, and the value of the ring should be on the bottom. So what should we subtract on top?
297.5.
Okay.
Minus 189.5.
Good. And then on bottom you would have Good. Okay. So those I think might have been a little bit more confusing since both had dollar amounts, right? Okay. But if we're going to insure a ring for a certain amount, that's going to be our, if we have a value of the ring, insure it for that much, that's going to be our input, and then we want to know how much it costs, right? If you go to an insurance agent, you're going to say, I have this much value that I want to insure. How much is it going to cost me, right? So that's an input-output idea. Yeah, you have a question?
I mean, okay. If I put the numbers backwards and then took out the negatives, because obviously they're both be negative after that, it's still fine.
That's all okay.
Okay.
That's
All
okay.
right.
All right, so on top we get, what, 108?
Yes,
Over 2,400?
Which gives you
5 cents?
Or points.
0.045.
Wait.
Yeah, 0.45, but you can get
Yeah, we'll leave it like that then. We'll leave it as 0.045. So when they divided it? Yeah. Okay. All right. So this is going to represent our slope, but this is the cost per dollar, right? It's 4.5 cents per dollar, essentially. And then the second part is asking what flat fee is charged by the insurance company. So again, relative to the linear model, what are you looking for? You're looking for the B, right? You're looking for how much they charge if you insure $0, right? So it's asking you for the y-intercept, right? And notice these problems are all set up a lot like this, right? Find the slope, find the y-intercept, and then use your model to answer other questions. Okay. So right now, we know the slope is 0.45. So how can we figure out what the B is? What do we do? Good. Look at one of the values of what we already have, right, for input and output. So, for example, if we have a $3,500 ring, that should cost us $189.50. Then we plug it in on this side. We'll have 3,500. So now we should be able to solve for B. What do you get when you multiply those two numbers on the right-hand side? Okay. And we subtract and get 32. So doesn't matter what kind of ring or jewelry you bring in, doesn't matter. You're always going to get charged $32 and then plus something depending on the value of the ring. That's what that says. If you have a business slant, this would be a representative of something that's called a fixed cost. Right? Doesn't matter how many goods you produce or sell, you have fixed costs like rent for a building, for example, would be a fixed cost. Doesn't matter if you make anything, you still have to pay the rent. Right? Same idea here. This is basically a fixed cost, a flat fee. Questions on that part? Okay. Let's look at C. How much does it cost to insure a $12,000 ring? Is that $12,000 representing an input or an output the way we've got things set up? That's an input, right? Because it's the cost of the value of the jewelry, right? Okay. So what do we do with that 12,000 then? Put it in for X. Good. So we have F of 12,000. So we'll have 0.045 times 12,000 plus the 32. And if you put that in a calculator, what do you end up with? That part okay? All right. Then the last part says, how expensive of a ring can you insure for $100? So is this an input or an output? That's an output, right? So then we want to solve for the X, correct? I'll be a jerk. I don't know why. All right. So we'll set our 100 equal to the function. So the first thing we would do is subtract the 32 and then divide by the 0.045. And when you divide by 0.045, what do you get?
1,500.
Oops. That was what you said. Any questions on that one at all? It's okay? All right. I'll leave the last one there for you for practice. So you have another one to practice on. So let's go ahead and start talking about some new stuff today. So it switches gears a little bit, but it's going to put some stuff together that we've already talked about. So section 2.6 talks about transformations of graphs. We did a little bit with transformations of graphs, even though we didn't call it that. Back when we started building up our library of functions, I think in section 2, if I'm right. Basically, all in that section we kind of did them one at a time. In this section, we're going to talk about putting them all together, and then also talk about what happens when you change things in the x direction versus. Did I give you an extra one? Sorry. What happens when you change things from the x direction as well as the y? So let's look at the first example here. Where you've got the function f of x equals negative, the opposite of x minus 6 cubed, and then a plus 3. So let's not worry about the minus 6 to start with, because the other ones we've already talked about, those kind of transformations. Remember when we mentioned about how things get moved around? We said we wanted to identify a base graph first, right? Looking at the way this is set up, what do you think we would use for our base graph?
X to the third.
Yeah, the x to the third, right? That cube part, correct? That's the part that we want to use for our base graph. What did x cubed look like when you graph it? Yeah, it looks like that S shape this way, right? Okay, so that's going to be our base graph that we'll start with. So remember that certainly crosses at the origin, also goes through 1, 1, and 2, 8. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. So we have a graph that looks like that, roughly. Okay. Shrink it a little bit so you can get on the same screen here. All right, so our base graph is y equals x cubed. Let's talk about a couple of the things that we see and what transformations they have. So remember again, we talked about the idea of being something that's inside the function and something that's outside the function, right? Our function here is x cubed. That negative sign, is that on the inside or the outside? Outside, right? Remember, if it's on the outside, it affects what? Input or output? Output, right? If it's on the outside, it affects the output, right? Remember what the negative did? It flips it upside down, right? Affects the output, so it flips it upside down. A negative sign multiplied always does a flip. This is on the outside and affecting the output. Output is up, down, so it's flipping it upside down, right? Okay. So I'm going to write out what the transformations are, and then we'll put them all together when we actually graph it. So that first transformation that we have is that it does a reflection, a flip, if you will, of reflection about the x-axis. I know it seems kind of backwards since I said we're doing an output. Remember, x-axis is horizontal. When we flip it, we're affecting the vertical, right? I'll do number 2 here in a second. I'm going to list the third one as that what happens on the end. I'm going to come back to that -6 because we haven't done things affecting the inputs. Okay. Notice I'm going from left to right. I see a negative sign, I see a -6, and I see a +3. So I'm just going from left to right as I go here. Okay. All right. +3. That's on the outside again, so it affects the output. What does the +3 do? Yeah, it shifts it up, right? It goes up 3 units. Okay. So let's go back and talk about the second one here, and that's that -6. That -6 is that on the inside or the outside? Inside, right? So since it's on the inside, it will affect the input, right? It's going to affect the x's. So this kind of thing is going to do something in the x direction. Okay. Now notice when we added +3, that's going to do a shift up or down, right? So since this is subtracted, we would expect something to be shifted again, right? So it's just a matter of which way does it go. So it's kind of a little bit weird as far as inputs go. But let's do a specific example here, and then I'll come back to this one. Let me actually just graph some things so that we can actually see it, perhaps. Move it on a graph here. So let me just put in something that looks like this. All right, so first thing I'm going to do is just move this back over to 0. All right, so notice here, right now I just have the graph of y equals x cubed. Notice I've got it written as x minus a number, right? So let's see what happens when I make that number bigger. So if I just grab this and pull it, what's happening to the graph? It's going to the right, isn't it? Even though I'm subtracting the number off, it's shifting it to the positive x direction, right? It's kind of backwards, isn't it? Versus if I go subtract a negative or add a number, which way does it go? It goes to the left, doesn't it? Yeah. Yep. So let's go back over here then and write this down. That -6 will shift the graph right 6 units. Okay. I put them in this order because this is the order that you get as I go from left to right as I read across, right? I've got negative sign, then the -6, then the +3. That's why I put them in that order. I'm just reading from left to right across. Okay. All right, so doing our transformations now, first thing we would do is flip it upside down. So if I do this in red here, flipping it upside down makes it look like that, right? That's step 1. Yeah. Then the next step would be to do what? I want to take that red graph and do what with it? Yeah, use it 6 units to the right. And that's why I've got these dots on here. It helps me keep track of things. I'll take this dot right here and shift it 6 units to the right. 1, 2, 3, 4, 5, 6. This one also goes 6 units to here, to here, to here, to here. So there's a green one that I'm drawing here is step 2. And then finally, what are we going to do with that green graph? Move it up 3, right? So this point will go 1, 2, 3 here. This point will go 1, 2, 3 here. 1, 2, 3 here. Here. 1, 2, 3 here. And draw. So this last one is the final one. Okay. So notice we're just doing it step by step, right? Moving each one. Any questions about how we identify the transformations? That's kind of step one, right? Getting the different pieces. Questions on that one? All right, let's do the next one here. I've got this one written a little bit differently. It's got g of x is equal to 1 minus absolute value of x plus 3, and then all over 2. First, let's identify what the base function should be, what your base graph should be. What should your base graph be here? Absolute value. Fantastic. Good. So our base graph should be y equals absolute value of x. What does absolute value look like? That V shape, right? Good. Absolutely. So my graph will start that way, and if I can draw, worth a darn. Good. So before we identify the transformations, and I like to read from left to right, let's write it kind of in a standard-ish form here. Let me take that 1/2, oops, and put it literally out in front of the absolute value, and put the plus 1 on the end. Notice that kind of fits like what we had in the previous example. That previous example we had f of x was negative x minus 6 cubed plus 3. That was the previous example, right? Okay. I had the number that was multiplied out in front first, and then the shift at the end, all right? So I just kind of just rearranged it so I can see it better that way. How many different transformations do you see? 4. I see 4 of them, right? I've got that negative, that constant multiplied, that shift, and that shift. Right? There's 4 of them. Okay? Let's go through them in order from left to right. That negative tells you to do what? Flipped it over the x-axis. Good. Now I come to the 1/2. Again, the 1/2 is on the outside, so it affects the output, right? On the outside affects the output, correct? Okay. What is that 1/2 when you multiply? What does it do? It compresses it down, right? By a factor of 1/2, makes it flatter. Okay. So the vertical compression by a factor of 1/2. Next thing we hit is what? Going from left to right. Next thing we hit is the plus 3, the shift. No, it's a plus 3. Is that on the inside or the outside? Inside. So does it affect the x or the y? And the x. And again, we're kind of backward for the x's, right? The plus 3 will shift it left. Good. So we'll shift left 3. Finally, what's the next thing you see? The plus 1. What's it going to do? Good up 1. Good. Shift up 1. Okay. Are we good with? Yes. Remember on the inside, so the adding or subtracting on the inside affects the x's, right? It's basically backward. Okay, so when you have a plus, it's going to go in the left direction. If you have a minus, it goes in the right direction. Yeah, it feels kind of backward, right? But again, if I kind of go back over, I closed it. Oh, I didn't. I can grab this thing. So notice that if I make those numbers positive, subtract a negative, notice it keeps going more and more to the left. Versus if I subtract a number off, it goes to the right. Okay. So anytime it always goes when it's on the inside, it kind of does the opposite of what you would expect it to do. Are we okay with identifying the transformations? So now let's go through step by step here to get the picture. First thing we're going to do is reflect it. That's step one. What's next? Good. Yeah, it would be a vertical compression by a factor of a half, right? So this is going to make it half as tall. So this point, and again, sometimes it's helpful to identify the points, right? This is at -2, so it'll be at -1. This was at -4, so it'll be at -2, right? So that's the second step, making it half as tall, smashing it towards the x-axis. Third thing, shift it to the left 3, right? So all those points that we have identified are go left 3. So in particular, this is at the origin, so it'll go 1, 2, 3 right here. And then same shape though. That'll still go that way. That'll still go that way. And then finally, the very, very last one, everything goes up 1 unit, right? So same shape again, but just 1 unit higher. And again, that was the final one. Notice we're doing them a step at a time. My lines probably wouldn't be so wavy if I weren't writing on a computer screen, but that's okay. The idea makes sense? Okay. All right. We'll do more of these examples next time, as well as get into talking about the review for the exam on Monday. All right? So have a good one. We'll see you on